Hello viewers, Wagadaruna taking you through the story for A-Level Physics Paper 1, and this video I'm going to go through the topic of electronics and mainly triode valve. So this video is suitable for students in both Senior 5 and Senior 6 offering physics as part of their combination. So before we start, let's first look at the course outline of this topic, of this Physics Paper 1. So Physics Paper 1 is divided into 3 parts. The first part is mechanics, where 4 questions come from these topics. The second part is heat, where 3 questions come from these topics. And the last part is modern physics, where 3 questions come from these topics. So in modern physics, we have looked at part 1, part 2, part 3, part 4, and now we are on part 5, which is electronics. And here we are interested in calculations, but the full notes and trial questions are available in the book called Mastering A-Level Physics Paper 1. So it has clear notes, worked examples, and trial questions in all mechanics, heat, and modern physics. So if you need a copy, you can contact the author on any of these 2 contacts. So in this YouTube channel, we shall be interested in the worked examples found in this book. And a complete set of physics has 3 books. The first one is Physics Paper 1, then Physics Paper 2, and the last one is a topical question bank. If you also do Principal Mathematics, there are 3 books. One is Math Paper 1, Math Paper 2, and the topical question bank. Then if it is subsidiary math, it is only 1 book. And the rest are for O-Level Physics and Math. So this is O-Level Physics question bank with marking guides, O-Level Physics notes, and also Math topical question bank with answers. So for any of those copies, you can contact the author on these contacts. So we shall start our topic of electronics and mainly a triode valve. So we shall first make an illustration of a triode valve. So the triode valve has mainly 3 parts. It has an anode, it has a grid, and also a cathode. So first is the anode, which is positively charged. The grid, which is a spiral wire wound close to the cathode, but does not touch the cathode. I think you can see here, there's this grid and also this cathode, they are not in contact. So that electrons can pass through the spaces between its windings. So electrons, remember cathode, when it is heated, it will emit electrons by thermionic emission, so that they can pass through the grid and reach the anode. So those are the 3 parts of the triode valve we are interested in this video or in the syllabus. Now triode can be used as an amplifier, and in that there is a circuit diagram which can be drawn so that the triode valve acts as an amplifier. And that is what we are mainly interested in on this part of electronics. So in electronics for secondary schools of A-level, they are mainly interested in triode valve as a voltage amplifier. So this will be the circuit. They will have an input voltage Vin, which is an alternating current. If you see the symbol, it's a symbol for AC. It's a heater, so this is the setup of a triode valve. This is the anode, as we already seen. Cathode, heater. This is grid bias battery to provide the grid voltage. Then we have the load, RL. This will be the output voltage. This will be the high tension battery supply. And this is the milliammeter to measure the current. So what we are going to do, we are going to derive some of the formulas which we shall use in our calculations. Remember, Here we are interested in the calculation, so even the theory we give is brief and it's just to take us to the calculation bit of it. So the diagram above shows how a triode can be used as a voltage amplifier. So the grid must be negative always with respect to the anode while drawing the setup. Then the input alternating voltage Vin to be amplified causes alternating variations or changes in the grid bias voltage Vg. If the grid is positive with respect to the cathode, so this grid here, when you compare these two, the grid should be negative. But when you compare the grid and the cathode, it is the cathode which is negative and the grid will be positive. So if the grid is positive with respect to the cathode, more electrons pass and this causes grid current to flow. So when the grid is positive, it implies that electrons are attracted towards the positive. So more electrons will pass through the grid. So let us look at the terms used in this triode valve as an amplifier. And these are mostly the questions which they will be asked. They can ask for mutual conductance. So when they tell you to calculate the mutual conductance, you should remember that this is the ratio of the change in the anode current to change in the grid voltage at constant anode voltage. So this can be written mathematically as that mutual conductance is equal to change in anode current over change in grid voltage. Now the symbol for mutual conductance is Gm. So each time you see Gm, just know that it represents mutual conductance. And Ia represents the anode current. Vg represents the grid bias voltage. So delta is the change. So this is a change in anode current, change in grid voltage. So this is the expression for mutual conductance. What about amplification factor? So all these ones can be asked. So when they ask for amplification factor, just know that this is the ratio of the change in anode voltage to change in the grid voltage at constant anode current. So here it was constant anode voltage and we dealt with anode current and grid voltage. But now for amplification factor, it is anode current which is constant and we deal with anode voltage and grid voltage. So that means that amplification factor is equal to change in anode voltage over change in grid potential. So in symbols, amplification factor, so it's a repetition, you can just forward. So amplification factor is given by mu, and this is change in anode voltage, change in grid potential or grid voltage. When I cross multiply, take this one this side, I'll come up with change in anode voltage is equal to amplification factor multiplied by change in grid potential. So furthermore, we can try to rearrange this amplification factor. So when I get this amplification factor and I multiply both the numerator and denominator with change in anode current, remember they told us it is constant. So when I multiply by the change in anode current, I'll come up with this. So this is this part. Then I try to rearrange. What I will do, take this denominator this side to come up with this, then also get this and this to come up with this ratio. Then from there, if you remember that resistance is always, remember we know that V is equal to IR, therefore R is V over I. That means that this change in PD over change in current gives you resistance. anode resistance. So change in anode PD over change in anode current gives you anode resistance. And also this one you already saw under part 1 of mutual conductance, that is equal to change in anode current over change in grid potential. So this one will be equal to GM and this will be equal to RA. That gives us a new expression for amplification factor. That amplification factor is equal to anode resistance multiplied by the mutual conductance. So now you have seen two expressions for amplification factor. One was this, change in anode potential over change in grid potential. And now we have seen this one also, a product of anode current, anode resistance and mutual conductance. So what we are going to do, I shall first list down all the formulas, then we shall go to the calculations. So far you have seen mutual conductance and amplification factor. What about voltage gain? When they ask for voltage gain, just know that this is the ratio of output voltage to input voltage. So now we are going to derive this voltage gain. First we need to know that a triode valve acts as a voltage generator. Remember our circuit we drew when a triode valve is used as a voltage amplifier. So that means that E, the EMF, generator of EMF E, which is equal to amplification factor times the input alternating voltage. So EMF is equal to mu V in. Okay, then you also know that RA is the anode resistance, and anode resistance is the internal resistance, is what we call the internal resistance of the triode. That is why on the circuit diagram you did not see this RA, because it is an internal resistance and it is in series with the load resistance RL. So this RL was already shown in the diagram. So that means that the total resistance, because they are in series, we shall just add the two to come up with RA plus RL. So now that we know the total resistance and we know the EMF, we can get the current. So current through the load will be equal to EMF over total resistance. So this gives you EMF is this, so come and substitute for EMF, then total resistance is this, come and substitute for total resistance. So now that I've got the current through the load, I can get the output voltage. Output voltage is equal to the current through the load, which is anode current multiplied by the load resistance. So you have already got the current through the load, that is anode current. So what we shall do, we shall replace this with that expression and the current, and this one we shall leave it as it is. Then from there we can just rearrange to come up with this expression. So this will be the expression for output voltage. But remember, our interest is to get the voltage gain. And voltage gain, we saw it is the ratio of output voltage to input voltage. Therefore voltage gain, which is denoted by a symbol FV. So when you see FV, just know that it means voltage gain to be output voltage over input voltage, and output voltage is here, input voltage is V in. Come and substitute for V naught, which is the whole of this, which is here, divided by V in. That's why I multiplied by 1 over V in. Then from there I realized that this and this can cancel. When it cancels, remain with mu RL over RA plus RL. So that now we have seen the expression for voltage gain. So now there are three. There is mutual conductance, there is amplification factor, and there is now voltage gain, and also output voltage. So even output voltage, sometimes it can be asked. They can tell you to calculate the output voltage. So you need to also remember this expression. Or calculate voltage gain. So you need to also remember that expression. Okay. So furthermore, we can try to rearrange that voltage gain by remembering that amplification factor is equal to RA times GM. So that is anode resistance times mutual conductance. So when I remember that, I'll come and say that where there is mu, I'll put there this product to come up with this part. And when I rearrange, put resistances alone, I'll come up with this times GM. So product of resistances divided by sum of the resistances times mutual conductance gives you the voltage gain. So that's another way of expressing voltage gain. Also, you can express voltage gain by eliminating you can also express output voltage by eliminating the mu. Remember here in this part we had output voltage, but there was mu, which was the amplification factor. So what if I substitute for amplification factor? What do I get? So that means that I'll come up with this still, which is similar to this, and this GM, which is here, but I have to multiply it by V in, because I know that the output voltage is equal to voltage gain times the input voltage. So in summary, we have seen two formulas for voltage gain and also two formulas for output voltage. So voltage gain can be given in this form if the amplification factor is known, or in this form if the mutual conductance is known. Output voltage still can be given in this form if the amplification factor is known, or in this form if the mutual conductance is known. So the formula to use depends on what is given. If the amplification factor is given, use this for output voltage and this for voltage gain. But if the mutual conductance is given, use this for voltage gain and this for output voltage. So far we have looked at mutual conductance, we have looked at amplification factor, now we have looked at voltage gain and output voltage. And with those formulae, we can go through now these questions. Question 1 came from UNEB 2007, paper 1, question 8b, Roman 2, and it says a triode valve with mutual conductance of 3 exponent negative 3 ampere per volt and anode resistance 1 exponent 4 ohm is used as a single stage amplifier. So remember we said our triode valve we are interested in is when it is used as a voltage amplifier. If the load resistance is 3 exponent 4 ohm, calculate the voltage gain of the amplifier. So first of all, we shall first code down what is given. In this case, we are given the mutual conductance, we are given the anode resistance and the load resistance. Now, because we are given mutual conductance, then we shall use the other formula for voltage gain, which has mutual conductance, which is product over sum of the resistances times the mutual conductance. So substitute anode resistance, load resistance, anode resistance, load resistance, and then mutual conductance. So when you use a calculator, you will come up with 22.5, and that's what they wanted. It was voltage gain, meaning it has no units. So if it was amplification factor which was given, we would have used the other formula which has mu, but now it was mutual conductance, so use this one of product over sum of the resistances multiplied by mutual conductance. Then question 2 came from UNEB 2012, paper 1, question 10d, and it says a triode of mutual conductance 3 milliampere per volt and anode resistance of 10 kilo ohm is connected to a load resistance of 20 kilo ohm. Calculate the amplitude of the output signal if the amplitude of the input signal is 25 millivolt. So they want, in this case, when they say amplitude of the output signal, if you look at this amplitude of the input signal, it is in millivolt, meaning it is a voltage. Therefore, the amplitude of the output signal, they want output voltage. So still we shall interpret the question. We are given mutual conductance in milliampere per volt, so we change it to ampere per volt by multiplying by 10 to the power negative 3. Then the anode resistance was 10 kilo ohm, so we change it to ohms to give you 10,000 ohms. Then the load resistance was 20 kilo ohm, we multiply by 1,000 to give you 20,000 ohms. And the input signal was 25 millivolt. So you convert to volt by multiplying by 10 to the power negative 3. So now that output voltage, we use the expression for output voltage in terms of mutual conductance because that's what was given. If mu was given, we have used the other formula, but now we shall use the formula which has mutual conductance. So product over sum of the resistances times Gm times V in. After knowing the formula, we shall substitute anode resistance, load resistance, mutual conductance, input signal. And when I use a calculator, the whole of this gives me 0.5 volt. And that's what they wanted. Question 3 came from UNEB 1995, paper 1, question 8C, Roman 3, and says, a triode with mutual conductance 4 milliampere per volt and an anode resistance of 5 kilo ohm is connected to a load resistance of 10 kilo ohm. Assuming that the triode is operating under optimum conditions, estimate the output signal obtained for an alternating input of 25 millivolt. So this one still is similar to the one we have just done. They want also output voltage. So mutual conductance is that you convert to ampere per volt. Then anode resistance you convert to ohms. And the load resistance you also convert to ohms. And the input you also convert to volt. Then from there you shall quote the formula and then substitute anode resistance, load resistance, mutual conductance, input voltage to come up with 0.3333 volt. And that's what they wanted. Then question 4 came from UNEB 2008, paper 1, question 10D, Roman 1, and it says, a triode valve with an anode resistance of 3 ohm, of 3 exponent 3 ohm, is used as an amplifier. A sinusoidal alternating current of amplitude 0.5 volt is applied to the grid of the valve. Find the RMS value of the output voltage if the amplification factor is 15 and the anode load is 50 kilo ohm. That is the load resistance. So like we have always done, we shall first interpret the question. This is the anode resistance. Then we also have this input, a sinusoidal signal of this is applied, so it is an input. Then you have amplification factor, which is 15. And we have a load resistance, which is 50 kilo ohm, we convert to ohms. Okay. Then the question wants the RMS. So RMS, you have to first get the peak voltage. So output voltage is V0 is given by this. Now using the other formula, which has mu. So quote the formula, substitute amplification factor, input voltage, load resistance. Anode resistance, load resistance. So when I use a calculator, I'll come up with this as the output voltage. But remember, they want root mean square value. So you should remember that root mean square value is peak voltage over root 2. So come and get the peak voltage divided by root 2 to come up with the root mean square value of the output voltage. And that's what they wanted. Then question 5 says, a sinusoidal voltage of amplitude this is applied to the grid of a triode of amplification factor 10. If the anode resistance of the triode is 5 kilo ohm, what voltage will appear across the grid of 10 kilo ohm? So still shall interpret the question: input voltage, amplification factor, then the anode resistance you convert to ohms, and the load resistance you convert to ohms. Then from there you have to code the formula for V naught, because now amplification factor is used, that's why I use this formula. Amplification factor was given. Then substitute amplification factor, input voltage, load resistance, anode resistance, load resistance. And now I simplify the whole of this, gives you the answer they wanted. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on atomic physics. So if you are not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.